There's many ways to find astronomical objects as there are amateur astronomers doing it, all the way from star hopping and hunting around aimlessly to take you 5 minutes to find the simplest things, to people who have computers hooked up to their telescope where all they do is type in the number or name of the object and it turns to it automatically. I don't have any complaint with any of those methods. I just want to make the distinction that if you're going to locate or find a celestial object that involves some activity on your part other than turning it over to a computer. Me, personally, I like to be as far away from computers as possible when I'm out under the stars observing. I fool with computers all day long and I like getting away from them. And it's the methods that I'm going to show you tonight work without any sort of electronic equipment at all. If you like to eat fish, you can go fishing and catch a fish and say that you've caught it and then bring it home and clean it and cook it and serve it, and you have caught that fish. But if you go to the store and get one, the end result is kind of the same. You still get to enjoy the fish, but don't tell anybody you caught it because you didn't, somebody else did. So that's my distinction on the different ways of finding celestial objects. The ones I'm going to refer to are ones where you actually find them. It's not one of the easiest things in the world. Few things that are worthwhile are also easy. Most things require a little bit of effort on your part. If something was easy, anybody could do it and then it wouldn't be special. So it's a technique that you learn to use with your telescope. If you don't learn how to find anything, you'll quickly get discouraged and the telescope will wind up in the attic. After you look at the moon and a couple of planets when you get a new telescope, then what do? That's kind of the end of the line for most people because they don't know what else is up there or what's good to look at and how to find it. If they have even seen a picture, say from the Hubble telescope, they say, I'd like to see that with my telescope, but you know, wish in one hand, it doesn't automatically pop into your telescope. You don't know what to do next. Some of the most rewarding objects, the Sombrero Galaxy, for example, the Dumbbell Nebula, these are things that are very much worth looking at, but they're among the harder to find, and we'll see how to do those this evening. It takes a little time to do it. Don't expect to be an expert your first night out. You'll make more mistakes than right things the first few times out, but that's how you learn. And it eventually gets where if you've been in it 60 years, you get to be the expert. And you'll develop your own methods, and someday you'll be showing other people how to do it. So this presentation is for people just getting started. That's what the short course is about, is getting started. First, one of my fundamental principles of life is give yourself a fighting chance. And in observing, that means you've got to collimate the optics of the telescope. There are all kinds of things online, including our own website, on how to align the optics of your telescope. If everything looks like a little fuzzy spot, then you won't be able to tell which fuzzy spots are stars and which ones are, say, a planetary nebula that you're trying to look for. So get it where the stars look sharp and other things are fuzzy only if they're supposed to be. Use a straight through finder. Every time I go on an observing session, I feel sorry for people who are trying to use right angle finders to find things because you have nothing to sight along. You don't even know what part of the sky you're in most of the time. You can eventually get where you can get by with one, but why? Use a straight through finder that allows you to aim at what you're looking at, like a rifle gun sight. You wouldn't want a right angle finder on that. They are easier on your neck. It's easier to look through a right angle finder than straight through, but why do that if you can't find anything with it? I suppose if you put on a blindfold, you could still cook dinner. But why? You know, it's just so much easier when you can see what you're looking at. Also, align the finder with the telescope. A lot of people have finders on their telescopes but have never made sure it aims the same way as the telescope. So you can get something perfectly centered in the finder, but it won't be in the eyepiece of the telescope. again, that's useless. If you have an equatorial mount, and I hope you do, aim the polar axis at Polaris. That way, the celestial coordinate system works for you. The telescope has its axis aligned with the Earth's axis, so all of the motions in the sky follow around that axis. The other axis is just for going north or south to find the particular object. Once you find it, you just track it by moving in that one direction. It makes everything so much easier to track it as well as find it, as we'll see. Here's a kind of a fine point, but it's important. Align the finder crosshairs with the celestial coordinates. In other words, turn the finder in its mount so that when you move on one axis, the stars will follow one crosshair. You turn on the other axis, the stars will follow the other crosshair. That makes them run north and east, or north and south, and east and west, so that they will match up with what you're looking at in a star map or an atlas. Otherwise, everything's diagonal and very confusing. Learn the sky, but not necessarily in one night. Eventually, learn the sky. Start out with the major constellations and brightest stars, and then gradually fill in with the lesser ones. And you don't even ever need to get all of them. For one thing, there are a dozen or so you can't even see from Memphis, and there are several that aren't worth seeing. So I'm not saying you have to learn every constellation, but at least know what the major ones look like so you'll know if something that you're looking for is even up or not. And learn where the most interesting objects are located in each constellation, so you can see generally where to point your telescope before you even get started. And here's a famous saying of mine: if you can't point your finger at the ring nebula, don't expect to be able to point your telescope at it either, unless, of course, you've delegated that to a computer. Quickly going over a few things that we went over in January, but these are all on our website. I always put this in to avoid problems. It's harder to find the sun than you might think because there's danger involved. First, cover up the finder so you don't accidentally look through it, or some kid in the neighborhood comes up, looks through the finder. That can cook their eyes too. You know, finder gathers a lot more light than just your naked eye. So even looking through a little finder telescope can be seriously injurious. So you find it by minimizing the shadow on the ground. The telescope presumably is out in the sunlight when you're trying to see the sun, so minimize its shadow on the ground and it'll be aimed at it. You can see the light coming through the eyepiece, and then center the light beam. Then project it onto a screen and focus it. Now you can get a fancy screen that attaches to your telescope, or you can just hold up a manila folder or a gray piece of paper. Plain white is kind of bright, so use something that's a little off-white, like a manila folder. It's kind of stiff, and focus it, and you'll have a very good image of the sun that way. If you ever want to look through the telescope at the sun directly, you have to keep most of the sunlight out of the telescope in the first place by putting a filter over the front end of the scope. Don't ever use a solar eyepiece filter because they tend to crack from the heat, and then all of a sudden all the sunlight comes out into your eye and can blind you just about instantly. You wouldn't even know what happened. The moon, a little inside story here. It doesn't require a computer to find, but it's not totally easy either, because if you have a big finder and the moon is bright, you can lose your night vision that way. It won't injure your eye permanently, but your night vision will suffer. So again, you can minimize the shadow of the tube on the ground and look for light coming out of the eyepiece, just like for the sun. Now here you can use a filter in the eyepiece. They make all kinds of lunar filters that you can put in that increase the contrast and make observing the features on the moon more enjoyable and easy. Or you can put an aperture stop over the front end of the telescope, just a big cap of cardboard with a couple of holes cut out on opposite sides, maybe 3 or 4 holes. You don't want just one hole, because that gives you like a 1-inch telescope and you lose the power and resolving power. But if you use the full diameter of the mirror, even through little holes, you get the full aperture of the telescope and all its power and resolving power, but a lot less light. So that's something you can use to make the moon less painful. If you've got a 10-inch telescope, there's a lot of light coming at you, and you want to cut that back. For naked eye stars, planets, so on, use your lowest power eyepiece for hunting. Remember last month when Tom talked about the formula for the power of a telescope, it's the focal length of the objective lens or mirror divided by the focal length of the eyepiece. So you want the longest eyepiece you have to give you the lowest power. And that gives you the widest field of view, and it makes it easiest to find things that way when you're looking at a wider field of view. Leave both eyes open. This may be counterintuitive if you're looking through an optical instrument, but those of you who used a microscope in the lab, I'm sure you've heard that the best way to do it is to keep both eyes open. If you go squinting, it hurts the muscles in your face, and after a while it gets tiresome, and that seems to spread to your brain, and you just don't have as sensitive an eye as if you're comfortable. They've done studies with sitting and standing, and if you're comfortable, you can see fainter things. Otherwise, you're concentrating on the pain of something, and it distracts you from it. So look through the finder with your better dominant eye, and then look at the sky with the other one, and that takes a little bit of practice. You move the telescope around so that you see the object moving towards the finder. Of course, it's the other way around, but when you're looking that way, it looks like the object's moving into the field of view of the finder. And when it enters the finder, since it's got an inverted field, it'll look like it's coming in from the wrong side, but that takes a couple of minutes to get used to, and after that, it becomes second nature to you. So the object enters the finder field from the wrong side, and then you line up the crosshairs in the finder, and then you look through the eyepiece, and there it is. Then you lock the declination axis, the one that lets you turn north and south, because once you found the object, it's not going north or south, it's going to be moving west across the sky. So all you need is to turn on your polar axis and find it and keep it in the field of view from then on. And then you can put in a higher power eyepiece if you want. You'll discover that most of your observing is done with the lower power eyepieces. Something like a galaxy. Those are big. They're not teensy little things for the most part. You'll need the whole field of view, and you'll use a lower eyepiece, lower power eyepiece. You need a big mirror to gather enough light to see it very well, because they tend to be faint, but they're not small. They don't need to be magnified much. In fact, you need the whole field of view to even see them. High powers are for things like planets and the moon and resolving double stars. And for me, I don't do that much. I nearly always just stick with the low power. Here's a kind of a scenario of finding something. The finder is the blue over on the right, the green are the actual stars. We move towards it with both eyes open. We see the star come in from the wrong side. You'd expect it to come in this way, but everything's upside down. In the real sky, this is north and south and east and west, but in the finder, it's south at the top and so on. So it's completely inverted. We get closer, and then bingo, we're right on it. When that happens, when your sky eye and your finder eye and the crosshairs in the finder all agree, the object should be in the eyepiece of the telescope. If not, you need to take out a few minutes and adjust the finder so that it is. Otherwise, everything you do is going to be a waste of time after that. Naked eye Messier objects. We've had a little bit about Messier before, including half of a program earlier this year. But Messier was the French astronomer who made a list of all kinds of little fuzzy things in the sky that weren't comets, so that you wouldn't mistakenly think you'd discovered a comet. There are 110 of them in his catalog. And we spend a lot of our time looking at these so-called Messier objects. Many of them are visible with the naked eye. Find it on a sky map if you want to look at one of these, such as the ones that are in our handbooks, the Amateur's Guide to the Messier Objects, or in the monthly Sky and Telescope charts, or any number of things that you find online. So see where to look. Locate it with the naked eye. If it's a naked eye object, you should be able to do that. Also, look at it with binoculars. Even before you get a telescope, you can see a lot of things in the sky with binoculars. Sometimes the view with binoculars is better than with a telescope. So always give it a look with binoculars. It'll help you see where it is so you can aim the telescope there. Or you may just want to stop with the binocular view, like the Pleiades or the Beehive cluster. That looks as good through the binoculars as it does through the telescope. Then you use the same procedure as for other bright planets and things. Use both eyes open, move the object into the finder, converge both images on the crosshairs, view the object through the eyepiece, same as the steps we just saw for a bright star or planet. Here's some examples of ones you can do that with. This is not an exhaustive list. These are just a few that came to mind. M44, the Beehive cluster in Cancer. M45, the Pleiades. M6 and 7 near the tail of Scorpius. We saw those at our last observing session. M35 in Gemini, the double cluster in Perseus. Here's the Beehive cluster, and you can see this pretty well through binoculars or the finder of your telescope. Another reason to have a finder is you can get wide field views of big things. Here's the Pleiades, same as the Subaru emblem, Pleiades, Subaru in Japanese. And you don't generally see all the nebulosity in it because the sky is usually brighter than they are, but you can certainly see the Pleiades on any clear winter night. M6 and 7. M6, here's the teapot of Sagittarius, and there's the spout. If you go across the top, there's M6. If you go across the tail of Scorpius, that leads you to M7 down here. And those are both naked eye objects, good in binoculars, even better in a telescope. Here's M6, the butterfly cluster. It's a very young cluster. It's mostly still blue giants, but a couple of them have turned into red giants. We'll see more about that in November when we go over the whole life cycle of stars. But this is a young star cluster, mostly blue. Here's the one I was referring to earlier, that Galileo may not have been the first one to see star clusters, because this one is known as Ptolemy's cluster, M7. It's the southernmost of all the Messier objects, down below the tail of the scorpion. And it's also very easy to find, easy to see. M35 in Gemini, right by Castor's foot, kind of like he's kicking a football right there in his instep. If you look at that, you can easily see it naked eye and in the finder and in the telescope. And you get this is it. It's also young with a few red giants in it. There's another little bonus cluster in the same field of view. Double cluster in Perseus, one of my favorites. It's actually, you find it from Cassiopeia, the W. Perseus is over here. And if you look like if this is the top of a V and here's the bottom, we'll wind up with a good view of the double cluster. That's also almost the same point as the radiant for the Perseid meteor shower coming up this week. They all seem to radiate from that spot in the sky as the Earth plows through the swarm of little particles. They seem to be streaming away from this point very close to the double cluster. Anyway, here's the double cluster, another young one with mostly blue stars, but there are a number of red giants scattered throughout. Nebulae, M42 in Orion, M8 in Sagittarius, the best ones of the opposite seasons of the year. Naked eye object, look in Orion's sword, you'll see the middle star in his sword is fuzzy. Look at it through the telescope and you will see pretty much that. You don't see the colors with the telescope because it takes more light to tickle the cones in your eye. You mainly just get the rod stimulated, so it looks like it's in black and white, but you do see something that looks a whole lot like that through our telescopes. Sagittarius, M8, the Lagoon Nebula. Follow the left side of the teapot up. Just follow that curve about an equal distance from the last couple of stars, and you'll see a fuzzy spot there. Aim your scope or binoculars at it, and you'll see the Lagoon Nebula. And with a nebula filter on, Ken Winters last time we had an observing session, showed us a glorious view of that where you could see all the dark lanes in here of the obscuring gases in the foreground. A galaxy, at least one galaxy, is visible to the naked eye, the Andromeda Galaxy M31. You find, well, the great square of Pegasus is over here off to the right. This is the northern star of the square. Andromeda comes out as two chains of stars from that star. Over the second pair of stars out from Pegasus, you'll easily see that star, New Andromeda, with the naked eye, and right next to it, some little fuzzy stuff. Aim your binoculars at it or the finder, and you will see something significant there. Aim your telescope, and here's 3 galaxies for the price of 1. This is M31, our nearest neighbor big galaxy, 2.5 million light years away. You're seeing light that started towards us 2.5 million years ago when you look at that spot. And it has 2 companion galaxies, M32, a little elliptical galaxy, and then another spiral galaxy, M110, the last of the Messier Objects out to the side here. The Milky Way galaxy, our galaxy, has 2 satellite galaxies, the Magellanic Clouds, which are visible in the southern hemisphere, but the Andromeda Galaxy also has a couple of satellites. All of these stars are Milky Way stars in the foreground. It's sort of like you're looking out the window of your house at another house across the street. And there's bugs on your screen, and that's what all of these little dots are here, is the stars in our galaxy in the foreground, and we're looking out millions of light years in the distance to this other island universe like our own galaxy. Globular clusters, M13 and Hercules, Omega Centauri, those are the 2 biggest and brightest ones. Here's the keystone of Hercules, located between Arcturus and Vega, very easy to find. And here's M13. You can sometimes see it with the naked eye, but sometimes not. It's right about 6 magnitude, so it's kind of borderline. But it's certainly worth looking at. I believe that's Rick's favorite object to look at and show off to people. 100,000 stars in a ball. M57 in Lyra, the Ring Nebula. If the object is located between 2 bright stars, then even if it's not visible to the naked eye, you can easily find it. If the stars are, you'll never see the Ring Nebula with the naked eye, probably not even in the finder. But if you look on a star map and locate the stars that surround it, then find those stars in your telescope, the object will be right where it's supposed to be. Here's the constellation Lyra. Here's where the Ring Nebula is located. It's very faint, but these stars are not. They're all 2nd and 3rd magnitude. So find that, aim your telescope, aim the finder at this spot, and there you'll see it. You don't see the colors again, but it looks like a little Cheerio in your eyepiece. You may or may not see the star in the center that cast off that shell of gases as it was expanding at the end of its life. Someday the sun will do something pretty much like this. Okay, now those are some of the easy ones. The ones that are a little harder are objects that are located directly north, east, south, or west of a well-known star. Well, M4 in Scorpius is located very close to Antares. Omega Centauri, straight south of Spica. M41, straight south of Sirius in Canis Major. And M27, just north of the head of the arrow. We'll look at each one of those on the star map and then see what you do in the sky. This time, you use the telescope and the finder to locate our starting point, the guide star. And then we trust the mounting of the telescope to carry us to the object when we turn in the right direction. Of course, you have to use a low-power eyepiece that increases your chances of success greatly. And you turn the telescope along the proper equatorial axis, going north or south or east or west. You never want to go diagonally because that leads to chaos and confusion. You always want to just turn on one axis of the telescope at a time. Here's M4, straight west of Antares. You can find Antares right in the heart of the Scorpion, then look through the eyepiece and move towards the west, and Antares and M4 will just appear. and it looks like this, very nice globular cluster. And it's certainly very easy to find. If you can find Antares, one of the brightest summer stars, you can find M4 by that method. In the winter, M41, open cluster just straight south of Sirius. Sirius is the brightest star in the sky. You should be able to find that. Look at that through your eyepiece. And while you're still looking through the eyepiece, just turn straight south and you will run into M41. Another young star cluster, a lot of bright blue stars. Here's one of the hardest things to find if you don't know what you're doing. The Dumbbell Nebula in Vulpecula, M27. It's kind of out in the middle of nowhere. It's in the middle of the summer triangle. Here's Albireo, the blue and gold double over here, but you'd have a long diagonal trip to make that. And here's Delphinus, ditto, diagonal. But if you find the little arrow in the summer triangle, go to the head of the arrow, Gamma Sagittae, and it is an orange star. Aim your telescope at that, and then while looking through the eyepiece, just go straight north and you'll run right into it. It takes about 2 seconds to do. Everybody else will still be calibrating their computers and you'll be looking at this through your telescope if you know that little trick. Just straight north from the head of the arrow, leads right to it. There's the star that did it all right there, the one right in the middle. Now this works over long distances in the sky if you have your equatorial mount lined up pretty well. Okay, so we have to align the mounting, and it doesn't take that long to do. And you try to position the telescope so the tube is parallel with the polar axis. And you do that by swinging the telescope around the polar axis and looking through the finder. If stars sweep back and forth across the finder, it's not lined up. You want them to be turning around inside the finder, and then it is lined up. This is what you're looking for. If your telescope is lined up with the equatorial mount, polar axis, and you rotate around the polar axis, any stars in that field will be making little circular arcs inside your finder field of view. If it's not, move the finder in such a direction that it is. You trial and error, move it to where it is. If it gets where there's still arcs, no matter what you do, that means the saddle the telescope sits in is crooked and you'll need to shim it up a little bit at one end or the other until you do get this. But then that will make sure that the telescope is lined up. Then you pick up the whole thing and turn it to where it's pointed at the north celestial pole, which is not exactly at Polaris, but towards the end of the bowl of the Big Dipper by about a Little Dipper by about 1 degree. So you go from the North Star a little bit towards the bowl and set the telescope down there, and that will be adequately aligned for any procedure in this way of doing things. Here's Omega Centauri. Now our horizon is about here, so it's way down in the sky. So it's a little tricky to find. If you notice in the sky map, Spica, the brightest star in Virgo, is directly north of it. You see that its right ascension is within a fraction of a smidgen of being the same. However, it's 36 degrees farther south. So you have a long ways to move to find it, but it'll work. I've done it many times if your alignment is really close. And of course, it's worth finding. It's like 3 or 4 M13s rolled into one. It's a tremendous object. I've seen it overhead in Australia, but here it's just above the horizon. You can only see it in the spring when it's just favorably suited. Now it's too late. Okay, you need to measure the diameter of the finder field in your telescope. Now why would you need to do that? So you'll know how big an area you're looking at. And you can match that up with a star chart, which is also calibrated in degrees. All you have to do, and this is kind of a passive endeavor, is aim at a star near the celestial equator, get it near one edge of your finder field, and see how long it takes to go drift across the field. And you know, this is a good time to go look through other people's telescopes, check back yours every now and then, see where that star is. If it takes 20 minutes to drift across the field, then your field must be 5 degrees in diameter, which is typical for a finder and a telescope. Then you can make a circle on a piece of paper and copy it onto a clear plastic sheet of the same size and lay it in your star atlas, and then you can see exactly what your finder field includes when you're looking at the sky. It's a very handy way to tell how much you're going to see. You've got to have some sort of idea of the scale of things. Do your eyepieces the same way. Suppose you put Saturn at one side of your eyepiece, and then 2 minutes later it goes off the other side. Well, then you know that your field of view with that eyepiece is a half a degree, 2/4. So you need to do that for each of your eyepieces, write them down, and then you again have an idea on your sky map how big a field of view you're actually going to see. And this is just a reminder that minutes of right ascension are not the same thing as minutes of declination. If you look back at the sky and the earth session, not real important. Okay, realign the crosshairs, same north, south, east, west. If you can turn your tube in the mount, you'll have to do this every time. If it has screws that lock it into position, then you won't have to. Sometimes it's easy to turn the telescope in the tube so that, in the mounting, so that it's easier to look in from the side. Well, then you'll have to realign the crosshairs. So what I do is just get up on a step stool and leave the telescope in the same position all the time and not have to rotate it in the tube and not have to realign the crosshairs. It saves a little effort that way. Also, make sure that what you're looking for is within the light gathering power of your telescope. If you're looking for some 15th magnitude planetary nebula and your telescope only reaches 12th magnitude, you might as well save time and look for something else. You're not going to see it. This is the formula for the limiting magnitude, 5 times the log of the aperture plus 9. So if you have a 4-inch diameter telescope, the log of 4 is 0.6 times 5 is 3 plus 9 is 12. You get a 12th magnitude limit on your telescope if you have a 4-inch telescope. This also works for your eye, by the way. If your eye is 1/4 of an inch in diameter, then we'd subtract 3 from 9, it gives 6. That tells you you can see 6 magnitude things with your eye if your pupil is still 1/4 of an inch in diameter. And finally, resolving a double star. If that's what you're looking at, you can resolve, if you have a 5-inch telescope, you can resolve stars that are 5 arc seconds apart. If you got a 4-inch telescope, they have to be 1 1/4 arc seconds apart to see them. And when you go to look up double stars and see if you're going to split them in your telescope, it'll tell you how far apart they are. And if it's out of the reach of your telescope, there's no point in even trying because you won't be able to see it. Okay, objects that are almost, we're getting a little harder here, almost north, east, south, or west of a well-known star. M80, globular cluster in Scorpius, and 104, the Sombrero Galaxy in Virgo, both well worth finding. But there's no star directly north, east, south, or west of them. If we use a star atlas, we can find usually a star that's kind of nearly north, east, south, or west of it. Now, here's kind of a thought question. If you're going to sweep across the sky and your object you're looking for is, say, 11 degrees east and 1/2 degree south, what do you do first? Do you try to estimate the 11 degrees east, and you can't see anything when you're there, and then go south? Or does it make more sense to do the 1/2 degree south while you're still on your starting point and then sweep across? Well, the second way, and that's the way the methods do. Use the template of your eyepiece and finder fields to see on the star chart just how much sky you're seeing. And then move, when you see the guide star, like Spica, for example, move it near the edge of the eyepiece. And if you know that that eyepiece has a 1 degree field, and you move it from the center to the edge, you've gone down 1/2 degree. So that may be what you need in order to run right into the object. And then you just, while you're looking through the eyepiece, not the finder, turn to the object as before. Here's a good example of that. M80, globular cluster near the head of Scorpius. This circle here is the 5-degree finder field, and this right here is a 1/2 degree eyepiece field. Now, if you start with Delta Scorpii, the middle star in the head of Scorpion, and then go towards the east, you'll miss it. There's nothing else straight north, east, south, or west. But if you take this star and you go down by a whole eyepiece field towards the south, while you're still there, just get it right off the edge, then go east, you'll run right into it. You see how that works there? You do your fine adjustment first, and then the long sweep afterwards. This is a quotation right out of the Messier book that we have. It's just copied right out of there. And here's M80, well worth looking at. Just as pretty as M4, but I would imagine most people don't look at it because it's a little harder to find. Okay, Sombrero Galaxy, right here. If you use Spica and go west, you'll go across the top of it and miss it. If you try to go 11 degrees over and then a degree or so down, you'll miss it. What you do is get Spica in the field, move south until it's at the edge, the north edge of a low power eyepiece, then go west about 11 degrees. Now, you're not estimating the 11 degrees. You'll know that's happened when you run into it. It'll be there in the eyepiece. And it's definitely worth seeing. We did this at the last observing session and saw the Sombrero Galaxy in Virgo. Very beautiful sight indeed. Another one, M92 in Hercules, and M10 in Ophiuchus, M64. These are ones where it looks like, if you just look at the star map, we're going to have to go diagonally. That's never a good idea, because diagonally is a combination of random chaos. You're not following the axes of the telescope or the celestial coordinate system. Catherine Delaney, a sweet lady in Pittsburgh when I was there in graduate school back in the 60s. She was sort of the Aunt B of the Amateur Astronomers Association of Pittsburgh, very motherly type, and took me in when I was there. And her expertise was in finding Messier objects. Now, as I said right at the beginning, I'm telling you my favorite way. She had an entirely different way. She used a very short focal length rich field telescope, no mounting. She would stay indoors and sit on the stairwell of her 2-story house and look out the window to find these objects with the telescope in her lap. Now, you may think that's doomed to failure, but she was the first one to receive the Astronomical League Award for finding all of the Messier objects. So, like I said, just to each his or her own. Well, anyway, she was the inspiration for me writing these handbooks, because I couldn't see doing it her way, because I had a F11 telescope that had a very narrow field of view, and her methods just would not work for me. Here was one of her handouts that she gave out at the meetings. She liked triangles. You could make a triangle here, and this star was somewhere on that line, or Ophiuchus divided up all kinds of ways, and here was one and here was another. And her favorite way to find M10 in Ophiuchus was to go 3/5 of the way from Vega to Antares. Now, you know, Vega and Antares are extremely far apart. In fact, they're 87 degrees apart in the sky. If your field of view is just under a degree, which is typical, you have to estimate that distance within 1% to get on M10. And that doesn't include getting off side to side. Just if you're straight on that line, you have to estimate within 1%. So I figured there's got to be a better way, or at least another way, and hence I came up with all my directions. This is sort of like, if you want to go from here to here, do you get in a Land Rover or something and cut across everybody's yard to do that? Or do you follow the natural coordinate system of the streets? South and west and south and west until you get to where you're going, turning only at well-marked intersections or landmarks. Well, since you can't estimate it, break it up into steps, each of which is an equatorial motion. So you find some kind of grouping of stars that is north, south, east, or west of the object, and bracket it, and then move. Let's see how that works. Her method of finding M92 in Hercules was to go, I think it was 15/64 of the way from Eta to Iota Hercules down this way, and that would lead you to it. You can see that if you use a straight north-south thing, it's not going to work. If you use pi Hercules, you'll miss it on top. If you use 69, you'll miss it on the south. Nothing else looks close. But what if you got right in between these to start? Then when you go north, you'll hit it. So in your finder, aim between pi and 69 Hercules, and then look through the eyepiece as you turn north, and you'll see the other Hercules cluster, which is almost as good as M13, but I bet it's not seen 1% of the time as M13 because it takes a little more effort to find it. Here's M10, 3/5 of the way from Vega to Antares. Again, nothing directly north, east, south, or west, but if you take these two stars in Ophiuchus, the great big coffee pot thing, on the west edge, there are two stars known as the Yed stars, Delta and Epsilon. If you go right between them and down, you'll come right to M10. And if you have a low enough field of view or in the finder, M12 is in the same picture, as we can see here. This is M10, and that's M12. And then you crank up your power and get a close look at those. And those are very much worth finding. Here's one. It's, again, a great one. The Black Eye Nebula, M64, in Coma Berenices. Looking around, you don't see any stars straight north, east, south, or west, especially these. These three stars make up the constellation. But if you look here and here, those two stars kind of bracket it. So if you start here with the finder, move along, you'll see those two stars come into view. And then if you center between them and then just turn up towards the west, you'll run right into it. Here's a page out of the first Messier guide that says that. Here's your alpha and beta. Start from one towards the other. You see the two little stars. You center between them, and then you move up to M64 will appear in the field of view. And it's certainly worth looking at. The Black Eye Galaxy, that is a strange looking thing, but it looks like that. You can see all the dark stuff in our telescopes. Okay, wrapping it up, as promised. Straight through finder, equatorial mounting, both aligned. Take advantage of the celestial coordinate system. Plan your procedures indoors in advance so you don't just stand around scratching your head saying, well, what am I going to look at next? Make a list of what you're going to look at. We actually send out a list with each observing notice, and I've sent it out to all the members and people on the observing list in January of what's good to look at each month at observing sessions. And you can just use that as a checklist. In fact, it's rigged up with check boxes so you can check them off. Use the Amateur's Guide to the Messier Objects, published by the Astronomical Society, available for $5 each at your local Astronomical Society gift store right down here. Volume 1 has 50 objects, Volume 2 has the other 60. Use that while you're learning, and you pick up the techniques. If a comet appears, the coordinates will be in Sky and Telescope. It's not going to be in any star atlas you look at, and it probably won't be on your computer either. You have to be able to find it on an atlas and then use this kind of method to turn to it with your telescope out at the observing sessions. Then you learn how to plan your own strategies. If something is, you're looking for some dim NGC galaxy that's not in the Messier catalog, find it on the Star Atlas, work out some procedure like this to find it. You can do these things yourself with a little bit of experience. Keep records in the logbook. Here's the Astronomical Society's Messier Objects recording form. You can put down when you see each one, the telescope you're using, the observing conditions, and so on. And when you get 80 of them done, you get a certificate. When you get all 110 done, you get another one. Also, it's a good idea to keep records. You know, that cross on the moon we were talking about earlier, I just happened to discover that and write it down in my logbook, and 30 years later, it turns out that was the first real observation of it. After somebody else discovered it, they back calculated, and the time that I had it recorded turned out to be the first known observation of it. So it pays to keep records. Okay.
How much did you get for that?
Pay was not the right word there. Okay, so those are the basic techniques, and I hope to see you using some of these at our next observing sessions, one of which will be tomorrow night, weather permitting, and then a week from tomorrow night. So that's the story on finding things. Thank you. And if you like, we have copies of the Messier guidebook